Okay, good day everyone. Welcome to Marinai's Powerhouse Team Review and Training Center. So this is Direct Current Circuits Part 15 already. No, we are now on Part 15 of DC Circuit. So our topic for today is Y-Delta Transformation. This is Part 1 of our topic for today. So again, my name is Engineer Reggie Marinay. So to our Filipino students, so you can call me Kuya Reg for short. Okay? So we are here to serve you guys. So let's start now our discussion. We have the Y delta connected resistances. So we have the Y or the star delta transformation. So okay, one application of Y delta transformation is in transformer. Transformer wherein we connect it in Y or in delta, and in electrical circuit wherein we made some analysis regarding Y system, delta system, and especially when we analyze the unbalanced system wherein we convert Y to delta or delta to Y. Okay, wherein in a three-phase system, it's better to analyze if you have a balanced system, it's good to analyze a Y system. If you have an unbalanced system, it's good to analyze the system into delta system, wherein if you are given a problem that is connected in Y, so you have to convert it into delta system if you have an unbalanced three-phase system. So those are just some application, and also somehow it has an application with the motor starter. We call this as the Y-Delta starter. Okay, so let us study. So we have the Y, or also known as the star, and then we have the delta transformation. So let us consider we have here a resistor that is connected in delta. Then we have resistors that is connected in Y. Okay. So let us have this in our board. Okay, so we have our, I will draw first our delta system. So this is our delta. Connected resistors. Okay, so we have here our Rx. We have our Ry. Then we have our Rz. And then we have the Y system. We have Ra, Rb, and Rc. So this is our Ra. Then we have our Rb and our Rc. Okay, so it is here in our board that, so if we are given resistors connected in delta, that can be converted into Y resistors, or vice versa. If we have the Y resistors, it can be converted into delta. So let us have the equation. So let us take a look here. Let us take a look here in our board here. So in here, we have the Rx. Our Rx simply equal to the sum of the product of Ra and Rb plus Rb times Rc plus Rc times Ra all over, okay? Take a look here. What is the opposite of our Rx? The opposite of our Rx is our Rc, okay? So it is shown here in our PowerPoint. So this is our Rx. That is the sum of AB plus BC plus AC resistors. Then divided by our RC. Okay. Then what about our RY? Okay. We have here our RY. Okay. So our RY will be equal to, so our RY is equal to RAB plus RBC plus RCA. And then what is the opposite resistance of RY? Okay? O, sino yung katapat niya? Yung opposite. So RY, we have our over all over RB. What about now for RZ? It's still equal to the sum of the product. The sum of the product and then divided by the opposite, which is RA. So as shown here in our PowerPoint, so take a look here. So makikita natin dito, yung RY natin, that is over RB. And our RZ is over RA. Okay? Then let's say we have a transformation. So earlier we have uh, a Y going to delta transformation. Okay? We have Y to delta transformation. So meaning we're given here our Y system, then we are going to convert into delta. And then now, we have here delta to star or delta to Y. So the given is in delta. And then what is the equivalent resistors in Y? So we have our RA. So take a look here, guys. So our RA is equal to XY over the sum of X, Y, and Z. Okay? So take a look here. We have our RA. This is our RA in our figure. Okay? So a simple technique is, okay, using your two finger, okay? So this is our a simple technique. Take a look here. Our RA is equal to RX. Okay? Take a look at these two. So that's equal to RX times RY. Okay? Then divided by the sum of X, Y, and Z. So take a look here again. We have RA. So that is equal to Rx times Ry all over the sum of the three resistors. Rx plus Ry plus Rz. Okay? So, what about for RB? So, for RB, we are using our two fingers. Okay? So, we have here, okay? So, this is Rx and Rz. Okay? RB is equal to Rx times Rz divided by Rx, Ry, and Rz. So, take a look here. So, we have our RB that's equal to X times Z, Rx times Rz all over the sum. What about now for RC? For our RC, we have these two fingers. Okay, take a look. Okay. We have our two fingers here. So, our RC is equal to Ry times Rz all over the sum of the three resistors. That's why in our PowerPoint, we have this. Our RC is Ry times Rz divided by Rx plus Ry plus Rz. Okay? Then, let us have this principle. I'm going to make this as our Ry. All of these are Ry. Meaning, we are talking here of identical resistors. Identical resistors in Y or delta connection. Okay? And then, our Rx, our Ry, and our Rz. Okay? Let us make this in R delta. R delta, R delta, and R delta. Okay? Well, we can have it Y to delta or delta to Y transformation. What will happen here? So let's say we are given a Y. We are going to make it in delta. So let's see. So let's say we have Y to delta transformation. What will happen here? So the given is Y. We're going to make it in delta. So what is our R delta? Here. Okay? In our principle, that's equal to the sum of the product. So the sum of the product of Ry and Ry, we have, anyway, what is Ry times Ry? So that is Ry squared. Okay? Then ry times ry here, so that is ry, another ry squared. So plus ry times ry, another ry squared. Okay? So, then what is the opposite? Opposite of r delta, sining katapat niya, we have here our ry. So, let us simplify this. Okay? So, we have 3ry squared here. 3ry squared. So, 3r sub y squared. Then, divided by r sub y. Okay. 1r sub y will cancel out. Okay? So, what will be left here is this one, obviously. Huh? We have here 3r sub y. So, we may say here that our r delta is equal to 3r y. Okay? What about if we have delta to y? What will happen here? So meaning, the given is delta, we are going to convert this into y. So, we have r sub y that is equal to, okay? So, by finger method, okay? Using the two-finger method, okay? So, we have this, our ry, since they are just identical. So, that's equal to r delta times r delta. R delta times r delta. Okay? All over the sum of the 3. So, therefore, it will be 3r delta. So, this will cancel out. Okay? 1r delta will cancel out. So, what will be left is ry that's equal to r delta over 3. So, ganun na lang mangyayari dyan, ha, mga kawerpa. So, what will happen now to our r delta? Let us cross-multiply our 3. So, therefore, that's equal to 3r sub y. No? So, they are just the same, right? So, r delta is 3r sub y. R delta is 3r sub y. No? Okay, if we are given identical resistors. Okay? This is identical resistors in Y or delta. Okay? So, basta tandaan nyo to ha, mga kawerpa. No? So, this is a simple technique. Yung 3, katabi niya, yung may tatlong buntot. 1, 2, 3. No? Tatlong buntot. Ulitin ko. Yung 3, katabi niya, yung may tatlong buntot. 1, 2, 3. So, that is our R sub Y. Okay? So, huwag nyo kakalimutan yan, ha? Okay? R delta is equal to 3 multiplied by RY, no? So, buntot. What's that in English? Tail. Okay. The 3, okay, that is beside to the 3 tails, no? Which is connected in Y. Okay? So, let us solve this problem. Number 1. Okay, problem number 1. A circuit consisting of 3 resistors rated. So we're given here 10, 15, and 20 ohms are connected in delta. So we have here, okay, so they are connected in delta. Again, we have 10, we have 15, we have 20. Okay? What will be the resistances of equivalent Y-connected load? Okay, so we are given here Y-connected load. Okay. By the way, also, we have some application here in alternator. If the alternator winding is connected in delta or Y, no, we may use this principle in analyzing alternators. Okay. Okay. So, that one. So, let's say we have here our RA. We have here our R sub B. Then, we have our R sub C. Okay. So, the question is, what will be the resistances of the equivalent Y load? So, connected in Y. Okay. So, we have here our RA. Okay, our RA will be equal to, again, so this will be delta going to y. Okay, the given is delta going to y. So our RA, okay, let's use the finger method. Okay, let's call this as a finger method. So we have here RA, we have this, okay, we have 10 times 15. Okay, 10 times 15. So let us put here 10 times 15 divided by 10 plus 15 plus 20. Okay, so let us calculate. Okay, so that is 10 times 15, then divided by, we have 10 plus 15 plus 20. So the answer would be 3.33. Okay. Okay, that is one answer. What about our RB now? We have our RB, use our two fingers here. Okay, our RB will be 15 times 20 all over 10 plus 15 plus 20. Okay, so we have 15 times 20 divided by 10 plus 15 plus 20. Okay, the answer would be 20 over 3 or 6.67. Okay, what about our RC? This is our RC using our finger method. That is 10 times 20. 10 times 20 all over 10 plus 15 plus 20. 10 times 20, then divided by, we have 10 plus 15 plus 20. So that is equal to 4.44. Okay, so these are our final answers. Okay, these three. So therefore, our answer would be letter, okay, so the answer is letter C. Okay, letter C. Okay, let's have now problem number 2. Let's go with problem number 2. Here. Okay, the equivalent Y element of 3 equal resistors, each equal to R, and connected in delta. So, in here, these resistors are connected in delta. So, take a look here, guys. No? Take a look here. The equivalent Y element. Therefore, the question is our RY. Take a look here. I will not draw anymore, so it is already here on the whiteboard. Okay? The equivalent Y element of 3 equal resistors, each equal to R, and connected in delta. So, meaning that is connected in delta is just simply equal to R. Okay? Equal to R. The question is, what will be our equivalent Y element, which is our RY? Okay? So, in our formula here, so, what is our RY? Because R delta is equal to 3 times RY, no? R delta is equal to 3. Oh, katabi niya yung may tatlong buntot. Okay, may tatlong buntot. Okay. So we have RY will be equal to R delta over 3. Since R delta is simply equal to R, just put here R. Okay. Then over 3. Okay, that is the answer. Okay, very easy. Okay, that's letter C. R over 3. Okay, let's go now to problem number 3. We have this problem number 3. Okay, I will draw first our circuit for problem number 3. Okay, here we have 10 ohm resistors. So we have here 10, 10. All values of resistors are 10. Okay? There. Okay. The question is our R total. Okay? This is our R total. That is the question here. What is the resistance? So this is our terminals A, this is B, then this is, this should be C, and this should be D. Okay? So there you are. All the value of resistors are 10 ohms. What is the question here? Find the equivalent resistance at terminals A and B. Okay? So we are asked to find the equivalent resistance at terminals A and B. So at terminals A and D, so these are the two terminals. So we have terminals A and terminals D. Okay? That one. Okay? What is the value of resistance here at terminals A and D? Okay. There are so many ways to solve this problem. Okay? Well, if we are to take a look at these three resistors, 10 ohm resistor here, 1, 2, 3. So what is their connection? Actually, their connection is just simply Y. No? Okay? So this is Y connected because there is a star point or a neutral point here. Because remember, a Y, it has a star point or a neutral point here. Okay? And then the three tails here. Now, this is connected in Y. Okay? And another option is we can convert this. What is the connection of these three resistors? They are connected in delta because this is just a line, so we can consider that this is just one point. They are just connected in delta, and also this portion, the 310 here. There are so many ways to solve this problem. I'll show to you this method. Later, I will show to you the delta. I will convert it in Y. So I will show first this Y. I will convert this into delta. Okay, so take a look. Okay, remember this is Y connected. I'll make this as delta connected. So we have this. I'll make this as delta. Okay, that one. And then we have here, I will make this as delta. That one. Okay. I will make it as R delta. So we have the 3R delta here. Okay. No problem because the resistors are identical. Okay. Again, what is our formula? So our R delta is equal to what? 3RY. 3RY. As shown in our formula, R delta is equal to 3RY. Okay? So what is our R delta here? Our R delta will now be equal to 3 times 10. Our RY is simply equal to 10 here. So this is our RY. So therefore, that is 30 ohms. That is 30 ohms. Okay? Now, we have 330 ohms here. Okay? We are going to replace this circuit. Okay? We're going to replace this circuit. Okay? I mean, we can erase this circuit. There. See? What will happen? Remember that this is R delta. which is equal to 30 ohms. This is 30, this is 30, and this is another 30. They are all connected in delta. These three 30 ohm resistors. Take a look what will happen here. What is the connection of this 10 ohm resistor to this 30 ohm resistor? Simply they are in parallel, right? So nakaparallel lang sila. Oh, bakit sir? Oh, kasi they have two nodes here. They have two common nodes. Okay? The first node and the second node. Okay? So they are just connected in parallel, the 10 and 30. What about the 10 and 30 here? They are also connected in parallel here. Okay? The same goes with these two. Okay? What is the value of the resistance? We have 30 in parallel with 10. So, of course, that is the product over the sum. So, we have here 30 times 10. We have 30 plus 10. Okay? So, we have 30 times 10, then divided by 30 plus 10, which is 40, right? So, the answer is 7.5. So, let us put here 7.5. Okay? For the two resistors here. So, take a look, guys. Take a look. So, we have here our 10 and 10 here. So, I will draw the circuit here. Okay. So, we have our 10 here. And we have our 30 ohm resistor here. Okay. Of course, we have our 2 points, A, and our point D. So, this is 10 and this is 30. Already 30. Okay. Take a look here, guys. So, we have a common node here. Okay. So, this is actually point B. I will make this as point E. It's point E. Let us consider this point E. B to E, we have the equivalent of 10 and 30, which is 7.5. Okay? That is our 7.5. So, this is our E. Okay, let's say this is our point E. So, I will put a resistor here and another resistor here. Okay? Okay. So, therefore, we have here 7.5 ohms and another 7.5 ohms here. Right? Okay, so meron ka ng dalawang 7.5. Okay, obviously, they are connected in series. Right? Because of this, we have 7.5 here on the upstream and the 7.5 on the downstream. Okay? So, we have here the equivalent of these two, obviously, that is equal to 15 ohms. So, therefore, we have here our 10. Take a look here, guys. So, we have here our 10. Then, we have here our 30. This is 10. This is 30. Okay? 10, 30. Then, we have here our 15. Let's put here our 15 ohms. There you are. Okay? So, we can solve directly this. Okay? This is our point A and our point D. So, therefore, our RAD, this is a simple series parallel circuit, right? So, series parallel na lang ito, mga kawerpa. O, sige, unahin muna natin. Let's go first with the parallel combination of 30 and 15. So, we have 30 times 15 over 30 plus 15. And then, we have to add because the combination of these two is in series with the 10 ohm resistor here. So, we have to add 10. Okay, so that is equal to what? Take a look, guys. Okay, so we have 30 times 15, then divided by, so that is 45. Okay, so that's 10, then plus 10, of course, that's equal to 20. That's equal to 20. Okay, so that's 20. Huh? Okay. What's the time? It's already 11:20. Okay. So, our answer now, guys, would be letter, okay, letter B. Okay. Very easy. Okay. So, we have here number 4 problem. We have this number 4 and number 5 problem. Okay, for number 4 and 5, so we have this circuit. Take a look. We have this circuit. Okay? The 2 ohm resistors here, these 3 2 ohm resistors, they are all connected in Y, actually. Well, it looks like letter T, but actually they are connected in Y. Okay? So, for number 4 and 5, so I will draw the circuit first for number 4 and 5. Okay, so we have, it looks letter T. Okay. Okay, we have a 10-volt source. Okay, 10 volts. Then we have our 2 ohms. We have 2 here, 2, and we have another 2. Then we have 6 ohm resistor here. Okay, 6 ohm. Then we have another resistors here. Okay, that one. So we have another 6 ohm resistor. Okay, all resistances are in ohms. Okay, so we have A, B, C, and D. Okay, that one. So what is the question first here in our circuit? So find the equivalent resistance RT in the circuit shown. So what is the equivalent resistance RT? Take a look here. So again, this is connected in Y. So we are going to make this into delta. Let's make this into delta. So we have that one. Okay. Then let us have here that one. Okay. So let us put here R delta. R delta and R delta. Okay. Again, what is our R delta? Our R delta simply equal to 3 multiplied by Ry. Okay. Then what is our Ry? So we have here 3, then our Ry. Okay. So we have here 2 ohms. 2. So 3 times 2. So that is 6 ohms. Okay. So take a look here, guys. I will going to erase this Y so that you will see a delta system here. The equivalent delta. So its value, the value of H is 6 ohms. Okay? What will happen? Take a look here. What will happen? Okay, so these are the nodes. There will be no more node B. Okay. Remember that it has a 6 ohm value. Okay? have all 6 ohms. Take a look here. What can you say about the 6 ohm here, the color black ink here, and the color red here, the color blue here? What is the connection? Well, that is just connected in parallel, right? Because there are 2 common nodes here, common node C and A. So they are just simply connected in parallel. What about these 2 resistors? They are just connected in parallel because there are 2 common nodes, C and common node D. So parallel na naman tong dalawan to. Okay? So, let us have now the equivalent circuit. We can have an equivalent circuit for node A and C. So, let's say, okay, well, it is obvious that 6 parallel with 6, 6 parallel with 6, this is identical resistors in parallel. What is, how to get that? That's equal to the branch resistance, which is 6 ohms, and then divided by the number of branches. So, our number of branches is just 1 and 2. So, only 2 branches. So, 6 over 2. So, the answer is 3 ohms. Okay? Let us draw the equivalent circuit here. This is the equivalent circuit. Let's say this is our point A. Okay. Then, this will be our 3 ohms. Okay. Here. This will be our node C. That one. This is our 3. This is our node C. Then this is 3 ohms. Okay. Take a look. Here, guys. This is our 10 volts. Okay. Remember, this is node A, node C, and node D. So this is our node D. Node D. And take a look here at our node D going to node A. There is a 6 ohm resistor here. So we have here this one. There you are. So we have here our 6 ohm resistor. Okay. Basically, the 6 ohm resistor is in parallel with our 10 volt source because they have 2 common nodes, A and D. This is just a common node. Okay? So that is just a common node. Okay? So take a look. What can you say about these 3 ohms and 3 ohm resistor? Obviously, they are connected in series, right? They're just connected in series. So, we have here, this is the equivalent circuit. Remember, this is our 10 volts. Okay. Remember, the 10 volts is in parallel with the 6 ohm resistor. Okay, we can put here our 6 ohm resistor. Okay. And then for 3 plus 3, so that is 6. So that's another 6 ohm resistor here. So they are basically connected in parallel, right? So this will be our point A and point D. Point A and point D. Okay? So this, at point A and D, what will be our equivalent resistance? Okay? So take a look at AD, no? Anthony Davis, no? AD. So let us have here our RAD, which is simply equal to our R total. Again, how to get? These are 2 resistors, identical resistors in parallel, which is equal to the branch resistance, which is 6, divided by the number of branches, wherein we have 2 branches. So that is 6 over 2. So the answer will be 3 ohms. Okay? That will be our answer. 3 ohms. Okay? And that will be letter C. Okay? Very easy. Okay, so we have number 5 problem. Take a look here at number 5. Find the output voltage V sub O in the circuit shown. There are so many ways to solve this problem. There are so many ways. So the question here, what is V sub O? Let's go back to our original problem here. Our V sub O, that is the output voltage at the 6 ohm resistor here. Okay? So that is the voltage at point C and point D. Where is point C and point D here? Okay. So take a look here. So this will be our V sub O. We have a voltmeter here. There you are. Okay. What is the voltage here? At point C and point D. Anyway, take a look here, guys. So the question V sub O, okay, for number 5, our V sub O here is, that is the output, okay? That is the output voltage, the voltage at the 6 ohm resistor, okay? Or that is the voltage at point C and point D. Take a look, point C and point D, okay? So I will redraw this circuit, okay, so that you have a better understanding here of our network or our circuit. I will redraw this circuit like this one, because the two 3 ohm resistors are connected in series. There you are. Okay, so this is our 10 volts. Okay, so, well, the 6 ohm will be here. That is 6 ohm. And then this is 3, and then this is 3. Take a look here. The question is the voltage at point C. So this is considered to be our point C, right? This is point C. And this is our point D. Okay? Point D. So, how to solve this? Let's say this is our V sub O. We have a voltmeter to measure the voltage at there. No? Or we can have here. Okay? Just the same. Okay. We can use here voltage divider. Okay? We can use voltage divider. What is our V sub O? V sub O is equal to the total voltage. Take a look. These two are purely parallel circuit. Okay? So this is 6 ohms. This is another 6 ohms. So the voltage here is 10 volts. The voltage here must also be 10 volts and 10 volts here. Right? Okay? So that's equal to the total voltage, which is 10, multiplied by the opposite resistance of V sub O. What is the opposite? We have 3. All over the sum of the 3 series resistors, which is 3 plus 3. Okay? 3 plus 3, which is 6 actually. So that is 30 over 6. The answer would be 5 volts. Okay? That is the answer. Simple as 5 volts. Okay? Well, this is one good application of the voltage divider theorem. Okay? Wherein you can also have calculate first your total resistance. Then, in getting the total resistance, you can get now the total current. Then you can use the voltage current divider theorem. Whatever the value of the current here must be multiplied by 3. So therefore, the current times the 3 here will be your output voltage. Well, that's a longer method. This is one good application of the voltage divider. Okay? So this will give you an easier solution. Okay? Then I have another easier solution. Pamor. Okay? What is a more easier? I think that's a wrong grammar. More easier. I have a more easier solution. Let's call this as the easiest. What is the easiest solution here? Take a look. This is by inspection. By inspection. What about here? By inspection. By visual inspection, we have 10 volts here, right? We have 10 volts here. 10 volts. The voltage here is 10 volts. The voltage here is also 10 volts, right? The voltage here is also 10 volts because they are all connected in parallel. But take a look here. They have two equal resistance. So they will share the voltage drops equally. So if the voltage here is 10 volts, since they are equal, so therefore, they will share equally. If this is 10, this is 3 and 3, this must be 5 and this must be 5. That should be divided by 2, isn't it? Okay? So, you just have to divide by 2, the 10 volts, because these two 3 ohm resistor, they are just equal. Okay? So, meaning, by visual inspection, without writing the solution, we can easily say that the voltage here is just 5 volts. Okay? Because this is 10, the voltage here is also 10, then they are just equal to resistors, just divide it by 2. So the answer is the voltage here must be 5, and the voltage here must also be 5. Okay? So they will share the voltage drops. Okay? So that's it. So the answer would be, okay, for number 5, that is letter D. Okay, for number 5, that is letter D. Okay, so that's it for today for the delta to Y transformation, Y to delta transformation. Okay, we will continue this later. Okay, so we'll continue this later. So I'll see you on the next video. Thank you.